All right, this is the Leetcode problem, minimum flips in binary tree to get result. This was a Google spring of 2023 high frequency question. Google asked this of like everyone coming in and interviewing there. Let's go over this problem and how it works. There are a few things to keep in mind that, this is a tree problem. Recursion is probably going to be the right answer. It's almost always the right answer with the tree problem, or you can do some iterative approach. But as soon as you see a tree, you should think, okay, is this going to be like a depth first search, breadth first search, an in-order traversal, level by level, what have you. It's going to be some sort of tree traversal. The other thing you should think about is just because you have a prompt that takes in a certain function signature, it doesn't mean you have to stick with that. You can change that signature, you can wrap it in something else, you can make it work for you. So if we look at this problem, I think the fastest way to do this is, instead of calculating just the minimum flips to get a certain result, is there's only two results that we care about. The result is either going to be true or false. There's nothing else. So I think we can calculate the minimum number of flips to get either result. And we can save some time doing a tree traversal. A good way to look at this is if we really look at what's the minimum number of flips to get a certain result, something like and, right? That's really simple. But you need to look at, well, what's the minimum way to get, say, trues on both branches? What's the minimum way then to either get true on one branch, false on the other, or vice versa, false true, or false false? You need the minimum of all of those. And you want to traverse your tree 4 times just to figure out what's the minimum number of flips to get an and into the state you want it. If you look at just how many flips does it get it to any state, you can do your tree traversal in just one go. Let's see this in action. Very simple, very straightforward. Now let's look at some of the rules. Or it's just looking at, it's either the sum of ways, or it's the minimum of the ways to make a true in your child branches. Or to get a false result from an or, you just add up the ways to get false from the child branches. But to get a true, it's going to be the minimum of any way that there's a true in the child branches. For an and, it's kind of the other way around. To get a true, it's going to be the sum of the ways to get a true. To get a false, it's going to be the minimum of the ways where you get any false from the child branches. For an XOR, to get a false, it's going to be the minimum of the ways that, both branches are the same value. And to get a true, it's going to be the minimum of ways that the branches are different values. And then for a not, that's really simple. You're just summing from the child branches and flipping them. Let's look at some code. This is a hard problem, but if you can conceptually get what I'm talking about, the code should be really, really straightforward. Okay, so we're going to define our own DFS on top of this for the minimum flips. It's just going to take a root, which is an optional tree node. And instead, it's going to return a tuple. Commits. Now, let's do the base cases first with recursion. It makes it a lot easier to think about it. So if root is none, well, there's nothing we can do. All right, so if the root value for this is 0, which means false, well, it's already false. So we'll say false. No flips make false. 1 to make it true. And it's really the opposite for the true case. Okay. Now we're going to do a little bit more of a depth first search. So we can recurse left. Okay. So now we have, what are the minimum flips to get whatever result, true or false, from the left and the right. All we have to do is implement the logical rules for the different operators.
Sure.
So let's just do them in order. So from the prompt, 2 is 4. So that's just going to be, for an OR, is just going to be what's the ways to get a false. So false from the left plus false from the right. And that's going to be the minimum of the ways that we can get a true. So that would be left false plus right true, left true, just right true, and then left true plus right false. Right, it's every way to do it. Then which one is 3? 3 in the AND. So the AND case is extremely similar. So what are ways to get a false? Well, with AND, false, there's more ways to make a false. So we're going to do the min over here. So it's the min of left false, right false, left false, plus right true, and then left true plus right false. And then the way to make it true is just both need to be true. So it's going to do left first, left 1 plus right. Very simple. Okay, so 4 is the XOR. So XOR, there's kind of 2 choices for each. 2 for true, 2 for false. So in the false case, it's going to be, are they the same? So if left is false and right is false, for left is true and right is true. And then for the true case, it's only if they're different. So if left is false plus right is true, or left is true plus right is false. All right, I think it's just no. So with the not, all we have to do is add them together and reverse them. So that means we'll take the true on left plus the true on right. That's our false case. And then it's the other way. So left 0, 0, it's right 0. Okay. Pretty straightforward, right? So then we just need to say, from our outer case, we just need to get all the types of flips we can do from the root. And then if we want true, return our flips to get a true, or we just return our flips to get a false. Okay, let's run it. Ooh. I had a typo. I have several typos. It's hard to do this not in an IDE where you get the red squiggles and all that. Okay, it worked. Fantastic. All right, let's submit, see what we get. Bam. No, I'll start the study plan later. And that's how you get this done. This is really straightforward. All you have to do is think a little bit out of the box about how you're going to traverse this tree and where you're going to return. And you can do this very efficiently without repeating where you're going. Comment below and I'll solve any Leetcode problem and walk you through exactly how to do it. Don't forget to subscribe to get more interview help and advice on how to become a software engineer and grow your software engineering career.